integer functions. Yesterday we said greatest integer functions sometimes have another name. What did we call them? Step functions, because, why are they called that? They look like a set of stair steps. The graph is gradually going uphill or even downhill. So we want to graph this. It's read f of x equals -3 times the greatest integer of x. So please draw a t-chart. Did you find it helpful yesterday to spread out your x-axis so you had more room to put in those decimal values? I think it's helpful. Let's go ahead and do that if you haven't already. Spread out your x-axis. I'm not going to worry about the y-axis. I think that's okay to leave. We're going to spread out that x-axis to give us a little more room to work. Now, when we're picking values for x, can we pick anything, or are we restricted on the numbers we can put in? We can pick anything. I'm going to start off with some easy numbers. 0, 1, 2. 0, 1, -1. Just pick 3 integers to get you started so you have at least a starting point to go off of. So if I put 0 in for x, the greatest integer of 0 is 0. And 0 times -3 is 0. As I find my points, I'm going to plot them on my graph. If I put 1 in, the greatest integer of 1 is 1. And 1 times -3? -3. So 1, -3. Remember, you spread out your x-axis, so 1 is over 1, -3. Put 2 in. The greatest integer of 2 is 2. And 2 times -3? -6. So 2, -6. Over to 2 and down 1, 2, 3, 4, 5, 6. Looks like a straight line, doesn't it? But we know better. We know this should be stair steps. We just need to pick more points. As I'm picking more points, I'm going to focus between 2 points to see if I can fill in this information. Let's focus between 0 and 1. Maybe 0.5? What is the greatest integer of 0.5? 0. Just a reminder of how we come up with that. 0, or 0.5 is between 0 and 1 on a number line. I want the greatest integer that's not bigger than 0.5. Well, 0.5 is between 0 and 1. Is it 1 bigger? I want the smaller integer. I want it to round down to the smaller number. It's going to be 0. And 0 times -3? It's still 0. So I'm going to go over to 0.5 and up to 0. I know those 2 points are going to be on the same stair step. I want to know how far over the stair step is going to go. So let's pick something closer to 1. 0.9? So the greatest integer of 0.9, the biggest integer not bigger than, or the largest integer not bigger than 0.9? The largest integer is 0. And 0 times -3? Still 0. So 0.9 means I'm going to get really close to 1, and I'm still at 0. What if I pick other numbers closer to 1? Maybe 0.999. That's really close to 1, isn't it? Almost 1. What is the greatest integer of 0.999? It's 0. And 0 times -3? It's still 0. So I'm going to get really, really close to 1, but it's still going to be 0. But when I put 1 in, it's going to drop down to -3. So obviously that has to be where our stair step ends. Another one's going to pick up right below it. What do I put where that stair step is going to end? An open circle. So at 1, 0, please put an open circle. Just have that look. Okay. That's okay. So it looks like my stair step is going to be 1 unit long. Open circle on the right, closed circle on the left. Let's go ahead and pick some points between 1 and 2 just to make sure we've got our first stair step correct. So between 1 and 2 I might put in, what's a good number? 1.5, I think that's a great number. So the greatest integer of 1.5 is 1, and 1 times negative 3? Negative 3. So 1 and a half, 1.5, and then down to negative 3. I know these two are going to be on the same stair step, but I want to know where the stair step ends. So let's pick something closer to 2. What might I put in? 1.9. So put 1.9 into our function. The greatest integer of 1.9 is 1, rounding down. And 1 times negative 3? Negative 3. 1.9, negative 3. So I know that stair step is going to continue all the way over to 1.9. What if I pick something even closer to 2? 1.999. That's really close. What's the greatest integer of 1.999? Still 1. And 1 times negative 3? It's negative 3. But I know if I put 2 in, it's going to drop down to negative 6. So that stair step has to be ending. What can I put there at 2, negative 3 to show that that stair step is ended? An open circle. Once you've got 2 stair steps established, I feel like we can go ahead and extend the pattern. Do you guys feel comfortable doing that after 2 stair steps? If not, you could pick more points until they're all filled in. But what I don't want you to do is just to draw 2 stair steps and be done with it. I want you to go ahead and continue this. I'm going to do a lot more stair steps. I know the stair step height difference is 3. Where do you think that 3 came from? See how we're multiplied by 3? So all of our integers are going to be over third integer. What's the negative doing to my graph? It's making it go down the stairs, right? If it was a positive, we would be going up the staircase. Remember, our graph should pass the vertical line test. It needs to represent a function. If it doesn't pass the vertical line test, something is off. It has to be a function. What would you say the domain is? All numbers. Do you think it would ever not be all numbers? I don't either. I think it's always going to be all numbers because remember, we don't have any restrictions. We can put whatever we want in for x. The domain is all numbers. What about our range? What kinds of numbers are we going to get out in the y column? Multiples of 3. Multiples of 3. If you take your graph and you smush it on the y-axis, all those y values are going to be 9, 6, 3, 0, negative 3, negative 6, negative 9, negative 12. They're all going to be multiples of 3. When you say, I don't want you to say all, it needs to be specifically integer multiples of 3. I don't want you to say all numbers multiples of 3. It needs to be all integers. Integer multiples of 3 is fine. Another way that you could do this range, and I'm kind of out of room, I'll come down here. I could list the range values. I could say negative 3, 0, 3, 6, 9, dot, dot, dot on both sides. That would be another way to list my range values. Today we're going to spend some more time practicing on these step functions, or greatest integer functions. Remember, they always need to pass the vertical line test. If they don't, something's off. Go back and check your stair steps. I have, I believe, 4 problems. time misses a lot.
I'm sure Bob's not going to be happy today.
Don't forget, second quarter has started. If you haven't turned in one of those homework assignments, chances are you have a 0%